So source transformation. So previous class we studied superposition theorem and linearity principle of any network. So now we have to complete in this chapter source transformation, Thevenin's theorem, Norton's theorem, and maximum power transfer theorem. So source transformation. What is a source transformation? So generally what sources we have in our electrical circuits? We have two types major sources are there. That is AC source and DC source, right? Alternating current and direct current. Now we are talking about, because resistance we are taking only into the picture, and so we are talking about the direct current, DC source only. In this DC source, how many types we have? We have independent source and dependent source, right? So dependent source, again we have four types: voltage control current source, voltage control voltage source, current controlled voltage source, current controlled voltage source, or current control current source. Four dependent, which is depending on other branch of the circuit or other source of the circuit, whatever. Now this is dependent. Another type is independent. So independent source in DC we have two types. One is voltage source, one is current source, right? So total we have six types on an average if we separate it: two independent and four dependent. So source transformation means we have to transform this voltage source to current source or current source to voltage source. This is called transformation. If I gave you one resistance and one voltage source, I will tell just transform this to another type. So what is another type? Current and resistance. I gave you voltage source and resistance minimum. Then it must be transformed to current source with resistance. That is called source transformation, vice versa. If I gave you current source and resistance, then you have to transform it to voltage source and resistance. That we will study. So this voltage source, whenever I use it, it must come with a series resistance. When current source, whenever I come across, it comes with parallel resistance. Let's see. The source transformation is the process of replacing a voltage source Vs, let us say Vs is the name for it, in series with a resistor R. Always voltage source with in series resistor R by a current source Is, name is Is, in parallel with a resistor R or vice versa. So keep in mind, voltage means resistance will be in series. Current means resistance in parallel. Why? Whenever the voltage source is coming, when you making voltage zero, what it means? It must be short circuit, right? So resistance must be in series, so that current should flow in that one. Whenever you are thinking about the current source with a resistance, current source should be open circuit when it should be zero. So resistance should be active there. So be careful, when resistance is active, current source must be in parallel with resistance. When voltage source with resistance, if we want resistance should be active, it should be in series with the voltage source, because we are shorting the voltage source, then only resistance will be active at the time. So that's the main thing. Now let's check the figure. This is the voltage source and with a series resistance, and here these terminals A and B, I want to replace this complete left side voltage source and resistance to the current source. How it will be? A current source and a parallel resistance, A and B same terminals. I am just rearranging this voltage source with a current source and this series resistance to the parallel to the current source. This is the transformation of the voltage. This will only applicable when the circuit have a linearity principle, Ohm's law, when it apply Ohm's law. Let's see. The two circuits in figure are equivalent, both are same, equivalent means provided they have the same voltage and current relation at terminal A and B. Same voltage and current relation. What is the voltage and current relation means? Ohm's law. V is equal to IR. If they have same voltage and current relation, then these both circuits are equivalent. Both are same, we can say. Just I transform voltage source to current source. Resistance value is same, but it is in series. Now here it is in parallel. If the sources are turned off, the equivalent resistance at terminal A, B in both circuits is R. That's I told you now. Why it is in resistance in series, why the resistance is in parallel. When these are becoming turned off. Now voltage source when it is turned off means there is a short circuit. So A and B resistance will be there. When current source is turned off means it has to be open circuit. Then between A and B resistance should be there. Right? So this is why this is both are equivalent. When the terminals AB are short circuited, the short circuit current flowing from A to B. When terminals A and B are short circuited, when this circuit is closed, the current will flow from Vs to the resistance and from A to B and come back. This is a one loop. So the current will not given by Ohm's law is nothing but ISC. That is called I short circuit at terminal A and B. When a terminal A and B is short circuited, then it is Vs divided by R, that is Vs divided by R, that is given by I short circuit. This Is is equal to this Is, same current source. It will act like a in the circuit. Now in the circuit on the left hand side and for the circuit on the right hand side, this is the Is and same resistance will be like this. Now another statement, thus Vs by R, if you rearrange this one, Vs by R is also known as Is, the source current for the second circuit or equivalent circuit. Then for two circuits be equivalent. So hence the source transformation requires that what we requires Vs is equal to Is times R or Is is equal to Vs by R, same Ohm's law. Okay. So this is called source transformation. Whenever you come across a voltage source with a series one resistance, if many are there, then join all together and make it one resistance, and with a voltage source you can rearrange with current source parallel with resistor. With example you can see, or one another basic laws we'll see. Okay, what we have to keep in mind? We should keep the following points in mind when dealing with the source transformation. What are the major points? Note that in that figure that the arrow of the current source is directed towards the positive terminal of the voltage source. See, current always, when it is voltage source is like this, plus and minus, up and down, then current should be always upwards. This is the first point. If the voltage source is reverse, minus and plus, the current source will be downwards. This you have to keep in mind, first point. Next, note that in that note that source transformation is not possible. Sometimes it is not possible. When R equal to 0, when resistance is equal to 0, we cannot transform source transformation because Ohm's law is not applicable. When R is 0, Ohm's law will be there. No, current will become infinity. V by R. R is 0, infinity. How can we put the current source there? We cannot keep it. So R is 0, it is not possible. So which in the case with an ideal voltage source, which is happen always with an ideal voltage source, it happens when resistance is 0. In the universe, in the nature, we doesn't have anything ideal. Okay, some resistance will always there with the source, like battery. Internal some resistance will be there because copper plates are there, hydrofluoric acid is there, or some neon battery is there, right? So some resistance will be there. So always it denotes with Vs, source voltage, and some resistance. That's called internal resistance. So it will never be 0. And we have to keep in mind R equal to 0. Then the source transformation not possible. Same for current. Okay, now come to the example. Two examples are there. Then we'll finish this source transformation in the class. Use the source transformation to find V0. So always see the question properly. Many ways to solve the any problem. To solve any problem, we have KCL, Kirchhoff's current law, Kirchhoff's voltage law, loop equations, nodal equations, right? So many methods are there. But see the question, which method I am asking, which method we have to proceed. Okay, I don't want exact answer. I want the steps, procedure. I want to know how much you know about this topic. That's the main motto of the subject. Okay, when I ask, use source transformation. When I ask, use Kirchhoff's current law, mesh analysis, node analysis, use that only. You can't use other things. So here we have to use source transformation to find V0. Where is the V0 in the circuit? There. In this 8 ohm resistance, we want plus minus V0. That's it. So remaining all we have to rearrange with the source transformation. Then we have to find V0. How we can step? What I told you in source transformation, any current source with a parallel resistance can be changed to voltage source with a series resistance. Can you see here? Where is the current source? This is the current source. and this is a parallel resistance. We can change it to voltage source. Now coming to here, there is a voltage source and there is a resistance. Can I change it to current source? Yes. This is a voltage source 12 ohms, 12 volts and 3 ohms is the resistance. Just convert it into current source and resistance. The 3 ohm resistance will come parallel here. This voltage source become current source by Ohm's law. V is equal to IR. So what is I? I is equal to V by I. 12 by 3. How much? 4. So 4 ampere current and in parallel 3 ohm resistance will come here. So like this you have to transform it. Just check what I am doing here. See, 3 ohms and 4 amps. I change this. 3 ohms and 12 volts I change to 3 ohms resistance in parallel, and that voltage source I changed with V by R. 12 divided by 3. It is 4 amperes. Because it is plus minus is the battery upwards, current should be upwards. So this is one time. Next step I have to again change this here. What? 3 ohms and 4 ohms. What is now? It become, what is V is equal to IR? 4 into 3. How much? 12 volts. So this is the voltage 12 volts. The same 4 ohm resistance will come in series with the voltage source. And 2 ohms resistance as it is, no change. 8 ohm resistance as it is, no change. So I change both current transformation to voltage and voltage transformation to current. I made it. This is the circuit. Now solve it. 4 plus 2 in series. So it become series, right? 4 plus 2, 6 ohms. Now this 6 ohms and 12 volts I can transform again to current source, right? So V is equal to IR, 4 into this 12 volts, how it is coming. Now next, this 4 and 12 I can transform into current source. How? V is equal to IR. Current I is equal to V by R. 12 divided by 4 plus 2, 6. That is 2 amperes. Now this 4 plus 2, 6 is become in parallel. So this is the transformation of these two resistance and this voltage source. It will come in here, and this 3 and 4 amperes as it is here, and 8 ohms is as it is, no change. Now we can see here this 6 ohms and 3 ohms both are in parallel. Now we have to rearrange with one single source and one resistance only. Then this 6 ohms, because we want V0, so here in 8 ohms, so we should not touch that one. At the end only we will calculate what is V0. First we make circuit simpler. Truncate, delete. I make one resistance, one source and one V0 what we want. That's it. So for that 6 ohms and 3 ohms become parallel. What is the parallel? 6 into 3 divided by 6 plus 3. 2 ohms. It become 2 ohms. Okay. Now this at this is completely all are in one node. This also down is another node. 2 nodes are there. So how many currents entering with this current source? Current in this node, current is leaving 2 amperes. Current is entering 4 amperes, right? So effective current will be 2 amperes. So I can rearrange this 4 and 2 amperes current with one current source with 2 amperes, because 4 is entering, 2 is leaving. 4 minus 2, how much? 2 amperes. And which is higher? 4 is higher. So the same direction will be there. If 2 is direction is higher, then it will be down. Okay, 4 is higher, so upward. So I can rearrange. 2 ampere is the current source upward, because here 4 amperes is the higher one, higher current direction. So 4 and minus 2, it become 2 amperes. Now 6 and 3 parallel become 2 amperes. So 2 ohms. 6, 3 parallel, 2 ohms. Now this is your final circuit. Now current division method. Just you can find what is I current in the 8 ohm resistance. Then once you got the current, multiply with the resistance, it will get the voltage. Simple method. So 2 amps is the total current. What is the current in 8 ohms? What is the current division method? Total current multiplied by other resistance divided by total resistance. Right? Total current 2 amperes. The other resistance, this is 2. So 2 into 2, 4. Taksim kullu resistance, that is 8 plus 2. So 4 divided by 10. 0.4 is the current. So once you get the 0.4 current here, what is the voltage? V0, IR. I is 0.4, R is 8. So 8 into 4. 3.2 volts. Let's check. Continuation. Same thing what I told. So I is now 4 ampere. Other resistance divided by total resistance 2 plus 8 into total current 2 amperes. 0.4 amperes. Now V0 is nothing but 8 into I. 8 is the resistance. I is the here 0.4. So 3.2 volts is your this one. Okay. They like this also we can find, in alternative method also we can find, no problem. So Last another example. Yeah, another example I will finish in 10 minutes, then you can go. So find Vx for figure 4.2, use source transformation. Now here some more complexity. What is the complexity here? We got a dependent voltage source. Dependent voltage source is here, right? So this voltage source we should not touch. We can use in the equations, you can calculate, but we cannot rearrange with the source transformation. If dependent voltage source is there, we cannot rearrange with the source transformation from voltage to current, current to voltage. You keep like that only. Okay. Only independent voltage source with resistance and independent current source with resistance can be transformed. That's the first point I told you. Okay, next, what we are doing now? How many voltage source and how many current source are there? 2 voltage sources are there here. So first transform this 6 volts to 2 ohms. 6 volts and 2 ohms. These are in series. So I can transform it into current source with a parallel resistance. So 6 volts and 2 ohms. What is the current? I is equal to V by R. So 6 divided by 2. How much? 3 amperes current. So 3 amperes current will come here and parallel 2 ohms resistance. Check here. Something I missed. Yeah. See, 3 amperes is the current in parallel 2 ohms. Now here 4 ohm resistance and this Vx I can okay, this also we can transform first. Okay, dependent also we can transform, no problem. So how? 4 ohms and this is a current. So multiply V is equal to IR. 4 into 0.25 Vx. How much? 1 Vx. That is Vx is the voltage source in series with the 4 ohms resistor. 4 ohms resistor. But only Vx cannot be changed. Vx is a dependent voltage value. So that we cannot change. Just in multiplication we can use it. So transform this one 0.4 ohms and in parallel current source 0.25 Vx. Just multiply V is equal to IR. Then you get Vx voltage source. That is 4 into 0.25 1. Now the parallel resistance will coming in series. So now this is the 2 voltage sources I converted into 1 voltage source and 1 current source. I converted into 1 current source and 1 voltage source. Now this is now in series voltage source. Now write the loop equation. See again. Where is that one? Next I can 4 ohms is there, this is there and this is there, right? Now these 2 ohms and these 2 ohms become parallel. These 2 ohms and these 2 ohms become parallel. So what is the 2 ohms, 2 ohms parallel? 1 ohm. Now this 1 ohm and 3 amperes. How much the voltage transformation? 1 ohm and 3 ampere. V is equal to IR. 3 into I1, 3 volts. So 3 volts is the voltage source and this 2 ohms parallel 1 ohms is coming here. So this is the in series. Now we become only one loop. Means one big circuit is coming here with no multiple loops like this. So we can write the loop equation for this. So minus 3 current is leaving I1. Current is leaving. So minus 3 plus 4 plus 1 5 5I plus Vx because current entering now. So plus Vx. Now current here also entering in 18 volts plus 18 is equal to 0. First loop equation. Keep it aside. Then we have to check another method to solve it. That is now in this one only. So what we are doing, applying KVL to loop containing only 3 volts. Let us take, we consider only this loop. This loop let us take because we want Vx. Otherwise no need of anything. But Vx is a dependent. So in between these 2 points we need Vx. So consider this one loop. So what we can write minus 3 plus I. Minus 3 plus 1I. Then current is entering in this loop. In this branch. So Vx. So plus Vx. This is one equation. So Vx is equal to 3 minus I. Rearrange this one. One method. Or you can write here also. This loop also you can take. We can write in this format. Current is leaving. So minus Vx plus 4I entering plus Vx plus 18 equal to 0 also we can write. 2 loop equations also separate we can write. One is enough but 2 options are there. You can use any one. First one is simple. Vx we got it. Vx is equal to 3 minus I. So what we have to do now? Substituting in the previous equation. In the last slide we got one equation. That is 15 plus 5I plus 3 minus I. Here Vx was there. So in the Vx terms, 3 minus I put. So I is equal to minus 4.5. If we use loop equation of this loop equation, in this loop also same will come. That is minus Vx plus 4I plus Vx plus 18. This loop equation. Okay. Now rearrange and substitute the value in the previous equation. I become minus 4.5. Now once you know the I minus 4.5, what is the Vx? Vx is nothing but 3 minus I. So 3 minus of minus, that is 4.5. 3 plus 4.5. It is 7.5 volts. So like these two examples are there, which is important for your mid exam. So Thevenin's theorem and Norton's theorem will finish in the next class.